Aloha and mahalo for joining me today in presenting my professional internship track experience with the Hawaiʻi Island Hawksbill Project for the completion of my Master's of Science in Tropical Conservation Biology and Environmental Science. Sorry, did you want to do an introduction?
You're rolling with it, so.
Okay, all right. So I'm Kelsey Meagher, and to start, I'm going to be discussing my professional path, giving a background to the project, talking about my experience, discussing the outcomes and deliverables, and sharing my concluding thoughts on the experience. So when I was getting my associate's degree at the Napa Valley College, I interned with the Napa Valley Wildlife Rescue Center, where I rescued and rehabilitated songbirds, participated in public outreach, and participated in public talks and events. This was followed by attaining my bachelor's degree at Sonoma State University and interning with the Sonoma County Wildlife Rescue Center, where I cleaned cages of the educational animals, gave tours to school groups, and assisted a vet in administering subcutaneous fluids. In my final years during my bachelor's studies, I was hired as a private contractor with the Hungry Owl Project to provide barn owl box maintenance to businesses and private landowners in Napa, Marin, and Sonoma counties. This journey prepared me to intern with the Hawaiʻi Island Hawksbill Project, which I will be sharing more in detail about during my talk. But first, I'd like to share some details about the Hawksbill sea turtle species, the scientific name being Erycmachales imbricata, and Hawaiian name Honuʻea. So there are two common species of turtles here in Hawaiʻi Island that I'm going to compare to the hawksbill. So we have the green sea turtle and the hawksbill sea turtle. And the hawksbill sea turtle gets its name from its hawk-like beak, while the green sea turtle has a more rounded head for eating limu and seagrass on rocks. Hawksbill sea turtles have overlapping scutes, whereas greens have a smooth carapace. This is an extensive list of the comparison between the two turtles. I'd like to highlight that the green sea turtle takes 25 to 35 years to mature, and the hawksbill sea turtle takes between 20 and 29 years to mature. The hawksbill sea turtle ranges from the tropical waters of the Atlantic, Pacific, and Indian Oceans. Their threats include overexploitation for their carapace, incidental capture in fishing gear, native and non-native predators, and climate change. The hawksbill sea turtles are found globally and face anthropogenic threats, which has led the International Union for the Conservation of Nature Resources to list hawksbills as endangered in 1968 and elevated their status to critically endangered in 1996. In 1975, they were protected under Appendix 1 of the Convention of International Trade in Endangered Species, which prohibits commercial trade. Hawksbills were listed as endangered under the Endangered Species Act on July 28, 1978, and hawksbills became endangered largely due to harvesting for their shells. So here are some examples of the products from the commercial trade. The meat is toxic to humans. Therefore, humans harvested them mainly for their carapace and ornamental purposes. While globally, hawksbill turtles have been overharvested for their shells, on the Hawaiʻi Island, they face other threats with native and non-native predation, and they have a distinct DNA that puts an extra layer of protection for our Honuʻea in the Hawaiian archipelago. So in the paper by Gauss et al. 2020, Hawaii hawksbills, a distinct and isolated nesting colony in the central North Pacific Ocean, revealed by mitochondrial DNA, discusses that the Hawaii hawksbill nesting population is the smallest, most genetically distinct in the West and East Pacific, which is why monitoring of this population is so crucial to its survival. This map from the Gauss et al. Paper shows that the hawksbill nesting colony locations used in the nesting stock structure and mixed stocked analyses. The haplotype frequencies for each nesting colony showing the node sizes corresponding to the sample sizes at each given site. So I like to point out the Hawaii pie chart The EILP 74 haplotypes was identified in almost 50% of the nesting females. And if you look across the study site, this haplotype is found nowhere else. So the female hawksbill sea turtles come up on the beach to lay their eggs approximately every 4 years to lay their clutch, which is an average of 180 eggs. Some of these eggs will hatch, and those hatchlings will make their way from the nest across the beach to the ocean, will grow and reach maturity in 2 to 3 decades before coming back onto the beach in which they were born to start the cycle over again. So the threats of hawksbills in Hawaii include non-native predators such as monkeys, rats, feral pigs, and cats. Native predators such as crabs, fish, and sharks. Human activity, including coastal development, marine debris, pollution, campfires, lanterns, flashlights, vehicular traffic, foot traffic, and fisheries bycatch. And climate change with rising temperatures, extreme weather, and high surf events, and sea level rise. And that's where we come in. Now that we have a little more knowledge of the hawksbill species, I'm going to now be talking about the Hawaiʻi Island Hawksbill Project. So the Hawaiʻi Island Hawksbill Project is a partnership between Hawaii Volcanoes National Park, U.S. Fish and Wildlife Service, National Marine Fisheries Service, the University of Hawaii, private landowners, and nonprofit organizations. The Hawaiʻi Island Hawksbill Project was founded by Hawaii Volcanoes Natural Resource Management Division after several incidences involving hawksbills were documented in the late 1980s. The Hawaiʻi Island Hawksbill Project began monitoring for hawksbill nesting activity in 1989, and tagging of nesting females began in 1991. With intensive monitoring efforts, including monitoring nesting beaches both inside and outside of the park, were initiated in 1993. The actions to recover hawksbill sea turtles in Hawaii in accordance with the Hawaiʻi Island Hawksbill Project Handbook includes stopping the direct harvest of hawksbill turtles and eggs through education and law enforcement, determining the population size, status, and trends through long-term regular nesting, beach, and in-water censuses, evaluating the genetic stock and diversity using DNA analyses, identifying and protecting primary hawksbill nesting and foraging areas, eliminating adverse effects of development on hawksbill nesting and foraging habitats, and finally, controlling the non-native predators of eggs and hatchlings, including the monkeys, feral cats, pigs, and in the Hawaiian Islands. So the project objectives of the Hawaiʻi Island Hawksbill Project, they have 5 major objectives. And over the course of the summer of 2019, I participated in each of these, which I will be showing you examples of: identifying the hawksbill nesting activity and collecting baseline data, managing and protecting the nesting habitat, protecting nests and ensuring hatchlings safely reach the ocean, controlling non-native predators and vegetation, and promoting public stewardship for marine ecosystems through educational outreach. Before I get started I would like to let you know that as a volunteer in the park, I had to adhere to the photo policies of this species, which is described in the Hawaiʻi Island Hawksbill Project Handbook. In a bit, you'll see me and a partner holding some hatchlings because we were informing a project manager of the yolk sacs that were protruding from the hatchlings plastron to confirm that the hatchlings were mature enough to be released and it was safe to do so. So now that I've discussed the Hawaiʻi Island Hawksbill Project, I will now be sharing my 4-month personal experience interning with this project from May through August of 2019. Because we're working with an endangered species, the protocols adheres to the Endangered Species Act guidelines as developed by NOAA and the NPS. The Hawaiʻi Island Hawksbill Project monitors for all hawksbill nesting activities. This map shows 14 known nesting beaches on the Big Island of Hawaii. For my internship, I was assigned to monitor the southern beaches, including Apua, Keaho, Halape, Kamehame, Punalu'u, Kahakahakea, Pahuai, Humuhumu, and Avili. The monitoring assignment would average 3 nights and 4 days. But before going out into the field, I would go to the office and record the previous turtle activity. I would find out what vehicle needed to go out into the field, what equipment we might need to take to stock up on, and any other information that the project manager had for us that we will need to know before heading out. One of the project's most active turtle beaches was Pahuai, and this is a photo of Pahuai Bay. And this is another photo of Pahuai to give you an idea of what we're looking for on the beach. You can see our footpaths in the dark sand up by the palm trees as we walk up and down the beach every hour from 5 p.m. to 6 a.m. And during my summer experience, this was the beach with the most hawksbill turtle nesting activity. So if you're facing the ocean at Pahuai and you turn to your left, you'll see what is referred to as Shell Beach. This photo shows the coral pathways used by volunteers to assist with clearly seeing at night with our red headlamps. And here's another picture of me doing a beach walk at Pahuai with the turtle bag, which carries all the supplies needed to tag and measure a turtle and mark a nest. I'd like to point out that the flagging colors in the turtle bag, orange is used to mark the observed turtle laying her eggs, pink is for possible, and blue is used to indicate that the nest had already been excavated and is complete. When doing our nightly beach walks, we're looking for signs of hatchling activity. So for example, we might find a couple of sets of hatchling tracks when we come up on the beach. In the event that we find a live hatchling on the beach, then we will ensure that it safely gets to the ocean and we'll record when we found the hatchling and when it went into the ocean into our logbook. Throughout this process, I learned that hatchlings emerge approximately every 55 to 70 days after being laid, depending on where the nest had been laid, either sunny or shady region. During my internship, I got to experience what it was like to discover an unknown nest because another volunteer witnessed 2 hatchlings on the beach that had come out of a large naupaka grouping. When we followed the tracks back to the beach, the nest was buried in naupaka, and myself and another volunteer had to carefully create a runway for the hatchlings that were emerging so that they could safely reach the ocean. Hatchlings imprint on their natal beach, impacting their adult behavior, influencing the hatchlings returning to the beach in which they were laid. And during a hatchling emergence, we allowed the hatchlings to find their way on their own unless they got really stuck in the naupaka. So given the funding, the beaches were monitored as often as possible. So for the summer of my internship experience, the crews did not overlap at the beach. And because the female Hawksbill sea turtles came up at night to lay the eggs, the first thing a volunteer would do when going out to the beach is to look for the Hawksbill tracks, both adult and hatchling from the previous night or early morning. So in this next slide, I'm going to ask 2 or 3 people to unmute their mics and tell me what do they see in this image. So whoever wants to guess first, go ahead.
They're buried. Are they right there? Is that a nest?
Okay, David votes nest. Okay, one other person.
It looks like tracks from a female.
Yes, these are turtle tracks. In fact, these are adult turtle tracks. And the females prefer to nest in sandy beaches close to the vegetation line. So this is just to give you an idea of what do turtle tracks look like? What are we looking for here? So very good. Thank you for participating. And I'm going to ask, oh, and here I got the little arrow showing the left front and rear flippers are going up on this side, and then the right front and rear flippers would be going up on the right side there. And then one more time, I'm going to ask one more person who didn't already participate, what do you see in this slide?
Are those baby turtle tracks?
Yes. Thank you. Yes, these are hatchling tracks. Very good. Thank you. Thank you for participating. Yeah, these are 2 sets of hatchling tracks. And I will show you in just a moment, yeah, the hatchlings, but yeah, this is an idea of what we're looking for. So great job, everyone. Thank you. So when we're doing our hourly beach walk at Pahuai, a volunteer noticed these hatchlings, and we needed to find the nest in which they hatched from. So we were concerned about these 2 because of their exposed yolk sacs, but we called the manager and she said it was okay to let them go into the ocean. We found these hatchlings coming out of the nest here, and we created this runway so that the hatchlings could easily and safely get to the ocean. We made the horizontal lines that you saw in the previous photos in the sand so we could easily see the hatchling tracks. Now I'm gonna show you a short video of 2 hatchlings from that same nest coming out of the sand at Pahuai. And because we didn't know of this nest until we started seeing hatchlings come out, we couldn't install a nest cage without disturbing the nest. So volunteers had to sit by this nest every hour as they were emerging day and night to monitor the ongoing hatchling activity and to protect against predation. Okay, it's about over. There we go. So, as mentioned, conversely, when we witness eggs being laid, we will make and install a nest cage, and a flag with the orange ribbon representing that we observe the turtle laying her eggs would be tied to the nest cage. The nest cages are installed to protect from predation, vehicular traffic, and human disturbance. Furthermore, nest cages are installed as soon as possible, ideally the morning after the observed nesting event. So with measuring a nest depression, the depression indicates that the hatchlings are getting ready to emerge. And after putting a nest cage on, about 60 days later, we will witness this nest depression. And the nest depression is measured to see how soon we might be seeing the hatchlings coming out of the sand. And we as volunteers would walk the beach after they hatch and would conduct a nest excavation. So after the hatchlings successfully reach the ocean, with the help of a project manager, we will excavate the nest to determine the success rate of the nest. Developed, underdeveloped, or empty shells. The volunteers would bury the eggshells to detract from the predators and would keep the pipped or partially developed turtles for DNA analyses. And pipped means the turtle head just came out, but that's all. So the specimen protocol for this includes identifying the location, nest number, turtle ID number, when it was laid, when it was excavated, the description of the species, and the volunteer's initials. And these specimens, like the partially developed turtles or underdeveloped, are sent to NOAA Pacific Island Fisheries for genetic testing. During my internship experience, I was able to add to the female Hawksbill turtle population data by tagging a new turtle. And this isn't it, but this is just an example, right? So this is, I tagged turtle 167. And in order to tag a turtle, 2 volunteers would bring 4 sides of a turtle box together to contain her. 1 volunteer would put a turtle towel over the turtle's head until the turtle had calmed down. And then a second volunteer would insert the tag into the pliers and tag 2 of the flippers. We tag 2 of the flippers so we have the least amount of contact with the sea turtle as possible. And after tagging, we would mark down the tag ID numbers, take off the turtle towel, lift up the box, and let her go back into the ocean. So here's an image of a female hawksbill turtle that came up during the day, which was a rare occurrence. If a turtle is seen on the beach during the day, the project manager would need to be called as soon as possible. And turtles are easily frightened during the day. So hence we take a photograph of the turtle to as part of the record. So, all right. So on the upper right is a view from the hike to Avili, and on the bottom left is the image of me setting up a possible nest coral ring and installing a turtle sign. And this is another view of Avili. While there was some activity out here, there was even more marine debris. So part of our job as a volunteer was to pick up as much marine debris on these beaches as possible. So some difficult situations that occurred while out on the field was I had a fever one night, and I resolved this by just resting at camp and drinking a lot of fluids. Another difficult situation happened when monitoring. There was 2 beach patrons that decided to sleep on the beach. And luckily our project manager was present, and we approached the situation by suggesting the patrons to move to another beach and enforce them to use their red light. Or if they didn't have a red light, we would offer them red cellophane to go over their white light. So to end this section of my talk, I'm going to show you another video of me releasing a couple hatchlings into the ocean at Pahuai. Goodbye, friends. Cool. So a requirement of the Masters of Science, Tropical Conservation Biology and Environmental Science internship track is to create some kind of deliverable, which is a tangible or intangible good or service for the host organization. So for my deliverable, I wrote a first grade lesson plan teaching students about the life cycle of a sea turtle and potential threats of a sea turtle. I adapted this to fit a first grade lesson at the Volcano School of Arts and Science. The phenomenon was the Hawksbill life cycle and threats to survival. The essential question that I was asking was, how do hatchlings survive on their own throughout their cycle and know exactly how to find the beach where they were born to make their nests? The third grade next generation science standard that I used for this lesson plan was to develop models to describe that organisms have unique and diverse life cycles, but all have in common birth, growth, reproduction, and death. So students were able to identify the structures and functions of a sea turtle, their physical characteristics, and their life cycle. Students played the game Turtle Hurdles, and at the end of the lesson sequence, applied what they had learned about the sea turtle's life cycle and demonstrate their knowledge through accurate play of the game. By participating in this lesson plan, students were able to identify the structures of a sea turtle and explain the functions by playing Turtle Hokey Pokey and filling out the sea turtle anatomy handout, explain the 4 stages of the sea turtle life cycle through watching the TED-Ed Survival of a Sea Turtle video, and identifying potential threats to sea turtles throughout their life cycle, whereby watching the TED-Ed Survival of a Sea Turtle video, playing the game Turtle Hurdles, and listening in on the adventures of Gary and Harry, A Tale of Two Turtles. And as for our implementation of this lesson, as mentioned, I showed students this TED-Ed video, The Survival of a Sea Turtle. And these were the different times that I stopped the video that had a significance in either life cycle change or threat to the sea turtles. Here are some examples of the students' work, drawing the life cycle stages and each threat in between. As you can see by these student examples, students showed that they learned the difference in the sea turtle life cycle stages and each of the threats along the way. So after reading The Adventures of Gary and Harry, A Tale of Two Turtles by Lisa Matsumoto, the assessment tool that was used was questions and a dialogue with the students, which included answering the questions of how can we help the turtles? What is threatening the turtles in this story? And how did the plastic get there? And the answer to that is the humans. So we got to help them out. Okay. So another activity I did with the students was a turtle hokey pokey. So the assessment was live and they learned from each other. And the students were co-teachers in the learning experience of learning all their different structures of a turtle. So for example, with the turtle hokey pokey, we would go, put your flipper in, put your flipper out, put your flipper in, shake it all about, right? So you get the idea. But we would do that for all our different structures and functions of our sea turtle. So for some, the Turtle Hurdles game, we talked about the sea turtle life history patterns and emphasized on the predators and other conservation issues and put information together to play the Turtle Hurdles game. This is an image of origami that I created. From left to right, there's a cat that's supposed to be like a mongoose head, sharks, mice, crabs, and then, of course, turtles. So I had fun doing that. But students learned about the conservation issues. And to start, I handed out the origami pieces that I created. And the students got to design to their designated zones. So crabs would be on the beach, sharks would be in the ocean, turtles would be on the land. And the turtles would start off as an egg, so kind of crunched up, and they would break out of their eggshells and run across to the beach, which was on the other side of the field, or excuse me, went across the ocean, which was on the other side of the field, and came back to the beach, which they were hatched to complete their life cycle. And when we finished the running and tagging part of the predator prey game, every student wanted to be a turtle. So after the game, I had all the students run to the open ocean and then back to the beach so they could start their turtle cycle over again. Here are some other examples of student work for the parts of a sea turtle handout created by the Minnesota Zoo. As you can see, some students, this is first grade, so could spell words like carapace, which is kind of hard, right? Whereas other students, I was just like, oh, just write the first initial. Yeah, that's good. So just giving them a little exposure to our sea turtle anatomy. And if I were to do this again, I would have students just to draw a line to the turtle parts. So something like that would be more effective. And to reflect on my lesson plan, A Tale of Two Turtles was received well. The Hokey Pokey was fun and students reminded me to add a tail. The survival of a sea turtle video and worksheet students participated in and they enjoyed it and they did a great job filling out the worksheets. And with the Turtle Hurdles, kids had a lot of fun with that, running up and down and being all these different animals. And for parts of a turtle worksheet, it was too difficult for some, so I would just revise with the just lines drawing worksheet. And this is a little slideshow of the students thanking me for coming into their classroom. And I just love to see how encouraged they are by their new Nahunu knowledge. I won't let it go on forever because there's like 30 of them, but just wanted to share that. And another activity that I got to participate in was a friend raiser at Naʻalehu, where I got to table with the field technician, Cody Backen, and we got to show students and parents the difference between a green sea turtle and a Hawksbill sea turtle. We also had on display adult female Hawksbill skulls and a scoot. So on the table, you can see next to Cody, long, beautiful blonde-haired woman, and the scoot, which is right in front of me, that's a large Hawksbill scoot, and the empty shell, Hawksbill shells, and coloring sheets for the kids to take home with them. And when talking with the kids and parents, we notified them that there are not only green sea turtles that you would like to, that you see basking on the beach, but there's also Hawksbill sea turtles that get their name from their hawk-like beak, and that females only come up at night to lay their eggs and spend the rest of their life in the ocean, which is why they're not as commonly seen. And I just wanted to share this quote from a Lillies et al. Publication that I think really helps sum up what we're trying to accomplish here in protecting this endangered species. So endangered hawksbill sea turtles, Ehrlichiotes imbricata, are particularly vulnerable to changes in thermal regimes because nest temperatures affect offspring sex, fitness, and survival. It is unclear whether hawksbills possess sufficient behavioral plasticity of nesting traits to persist within their climate niche, or whether accelerated changes in thermal conditions of nesting beaches will outpace phenotypic adaptation and require human intervention. So the tangible skills that I gained during my internship experience with the Hawaiʻi Island Hawksbill Turtle Project was gaining knowledge of the species, reading a lava terrain landscape, monitoring nesting females that come up on the beach by identifying them through their flipper tags, taking their straight carapace measurements and curved carapace width, documenting the initial sightings, when the turtle started digging and laying, covering, stopped covering, and when it returned to the ocean. These were all parts of the monitoring efforts taken while working on this project. And for my deliverables, I got the opportunity to teach a lesson plan that I wrote at the Volcano School of Art and Science, which informed me that I want to continue to be in the public awareness arena. With this knowledge, I like to be an informal science educator. Working with the Sea Turtle Project showed me how rigorous of work I can handle. And I was able to meet both mentally and physically challenging environments, which strengthened my passion towards the life I'm trying to care for. And I realized that I'm my best self when I'm out in creation, working on my own or with a small team of people. This is where community really grows and trust is strengthened with those who have shared values for the land and for the life that inhabits the land. And with that, I would love to give a big mahalo to Lisa Canali for pairing me with the Hawaiʻi Island Hawksbill Project, Lauren Kerpita for being my agency mentor and for reviewing my final report and presentation. And I'd also like to thank Cody Backen for teaching me about the project and for all her efforts she put into protecting this species. I also like to thank my TCBES classmates and professors and my parents and everyone along the way who came out today to support me in getting my master's here in Hawaii. And my email is here if you have any further questions or comments, and I'd be happy to answer any questions that you have. Thank you so much for your time.
Thank you.
Thanks, Kelsey.
You're welcome.
Hey!
Okay.
I learned more than I thought about the Hawksbill sea turtle. Thank you so much.
Oh, yeah, no problem.
If you have a question, please feel free to unmute your mic and just ask it.
I have a question. I don't know if you said it and I missed it, but what is the gestation period when they lay the egg to when they hatch? Maybe you said it and I missed it and I apologize. Approximately.
When they lay the egg and when they hatch. So that would be the 55 to 70 days. It fluctuates, yeah.
Just curious, okay.
Yeah.
George Balaz here. I've been hearing talks on the Big Islands Project since 1989, students and others. I want to say this was the most interesting, informative, and for your perspective as a volunteer, excellent job. Thank you so much.
Thank you, George. Thank you.
It's from this station.
Will these lessons be shared publicly?
Okay, that's a great question. So I took the Education 494 class as part of my master's. And I believe, I'll double check, but I believe the education department does publish those lesson plans. So I'll double check, but I'm pretty positive. Yes, it's published in the education department at UH Hilo.
What would cause a baby turtle to emerge from the nest without the yolk fully absorbed?
Natalie, that's a great question. It's just premature. Things happen. I don't have a great answer to that question.
Do you want to step in?
Well done. No, I will.
I have a question.
Who's that?
Sorry, I have a question concerning I know you didn't get to visit these beaches a lot, but on the north part of Hawaiʻi Island in the Kohala area, I didn't know that there were nests up there previously. Was that a new addition? Are they regularly nesting there, or were they just random happens?
Well, that's a good question. Thank you for asking, Eric. I know that there's a huge set of volunteers and members of the public that this project could not function without. So those members of the public would go out and monitor those beaches on the north side of the Big Island. Yeah, great question.
I have a question for you, Kelsey.
Yes.
It's from Becky.
Okay.
And Becky would like to know what part of your internship brought you the most joy?
Oh, that's a good question. Okay. What brought me? There's just so many highlights. I really love seeing the hatchlings, coming out of the sand. I thought that was amazing. And I don't know, just the whole experience of sleeping under the stars at night in my hammock in Hawaii. It was just like an experience like none other. And I'm just so grateful that I got to not only work in Hawaii and under the stars, but I also got to work with this wild endangered animal, the Hawksbill sea turtle. And yeah, I think that was the big one.
Another part of your question. Thank you for the answer. What would you consider your biggest contribution to the project?
Oh yeah, the biggest contribution to this project was adding a new female to their population data set. It was tagging that female that came up on the beach. That's like the most important thing. One of the most, but yeah.
What do you think are some of the missing pieces for Hawksbill conservation, or what did you kind of see during your internship that maybe were things that could be improved in the Hawksbill conservation on Hawaiʻi Island?
Yes, thank you. Is it Callie? Callie, thank you, Callie. Yeah, so what needs, this is very typical of conservation, right? But more funding, more volunteers, more monitoring of the Hawksbill behavior would be like the number one thing. I think that this project does a great job of doing the monitoring and the predator prevention and the outreach. Like everything that they're doing is great, but what's really needed is more hands in the pot, so to speak, to get full coverage.
Makes sense. Thank you.
You're welcome.
All right. It looks like maybe we don't have any more questions. And so, Kelsey, I just want to say thank you very much for today. We'll be editing a little part of this out because it's not for forever public consumption. And then it'll be up on the TCBES website and not website, excuse me, a YouTube channel for if you want to see it in the future. And George, I wrote down your information, and so Kelsey will find out about those lessons plans for you. So thank you all for coming, and I'm going to stop recording now. All right, and congratulations, Kelsey.